Welcome back to Analytics, Big Data and the Cloud here at Fantasyland Hotel in Edmonton, Alberta. I'm your host, Walter Schwabe. We're going to continue talking about the SKA. If you didn't tune into our previous interview, we're talking about the Square Kilometer Array, which is purported to be the largest science and technology project ever undertaken by us little humans here on Earth. And I'm speaking with a gentleman who's had a key role in what's called the Cyber SKA project, right?
That's correct.
I'm sitting here with Cameron Kiddle of Calgary Scientific. Hello, Cameron. How are you doing?
Nice to meet you.
Nice to meet you. So let's talk a little bit about the data that you generated in this project, which was a precursor to the bigger project that, as we understood, is scheduled to come online somewhere around 2024. But you guys have been working and crunching some data already. Let's talk about the types of data that you guys have already been working on with respect to this project.
Okay, so with Cyber SK, we've been looking at data coming from existing telescopes such as Arecibo, which is in Puerto Rico, or the EVLA in New Mexico. So existing telescopes and trying to address those data needs now. And so typically we deal in generating what are called image cubes, which is kind of what you're looking at of interest in radio astronomy. And the ones that we're looking now coming off of Arecibo are on the order of around, say, 300 gigabytes. So still a far cry from what will be coming down the road, where we're dealing with terabyte and even petabyte scale images.
That was a lot smaller than I expected.
You know, it's still a significant amount of data that
Sure.
isn't easily transferred between sites or to end users' device. And so
let's talk about that. How do you do that?
So we don't do that.
Oh.
And that's the key thing.
Okay.
Is what has been done is the data has been kept at the server location where process is being done. And so that's where Calgary Scientific fits in with our PureWeb product. And so PureWeb is really focused around web enabling and mobile enabling applications where the applications stay where they are and the data stays where it is.
I see.
And so really PureWeb then enables you to access that application remotely over the web, you know, interacting with it almost as if you were running it locally, but it's actually running on that remote server, accessing that remote data, and PureWeb is essentially, you know, passing the images that are rendered and then really intercepting all of the mouse actions and keyboard actions that users are doing to interact. So they're doing interactive visualization with the data over a remote connection so that they can access it really anywhere, anytime, from any device.
That makes a lot of sense.
Yeah.
So rather than transferring these impossible size files.
Yeah.
Okay, so can you get into a little bit about, you know, how were these locations, these teams at these other telescopes, how were they processing and working with the data before you guys came along?
I mean, typically, you know, radio astronomers have collected data and they've run it locally, either off of, you know, local systems at their university or even their laptop and so forth. But as the data is getting bigger and bigger, it's not becoming feasible to do that. You need much more high performance computing or capabilities to do the processing of the data, and furthermore, transferring and getting all of that data to where you want takes time. And so what this enables you is you can have one kind of central or even several distributed locations that actually keep the data, but when users come online and want to access it, they get access to that over the web.
Okay.
And they don't have to move the data. They don't have to really have the application installed on their local system. It's running remotely, and they can access it. And so it's, you know, much more convenient for them. They don't have to worry about moving the data. They don't have to worry about having the computing facilities to do that. That's all handled behind the scenes, and I can access it while I'm traveling, you know, from my laptop wherever I have wireless connectivity, or different devices as well.
So that's going to really increase the productivity levels of these folks, first of all. So second of all, let's talk a little bit about then, in terms of your increasing discovery, chances of discovery, because if they're spending more time working with the data that they, you know, already have or so on, you know, there's a larger chance that instead of having only a certain amount of time with the radio telescope, because if I understand that correctly, that's kind of how it works. You get a certain amount of time. You go and you try to pull down what you need, and then you go away and you crunch it. Right?
Yeah.
But let's talk a little bit about the business model behind this. So with you guys and your applications, is it pretty much a standard software model that you have going on from a business perspective? Like, how do you bill for it?
So in terms of this, at least for this particular project, it's a an in-kind contribution to the Cyber SKA project. But
how
for
would
us,
you bill for that?
typically, normally for clients, what we have is a software transformation kit. So it's a kit that enables people to transform their software that will enable it to access that software remotely. So we typically bill for the software transformation kit itself, and then a licensing fee, per concurrent user that's accessing the different servers.
Okay, so that's okay. That's pretty straightforward. So how long has Calgary Scientific been around?
So Calgary Scientific has been around for maybe 7 to 8 years, and really it started out in the space of medical imaging.
Oh, okay.
So it was actually looking at how can we make medical imaging available over the web, and then eventually also over mobile devices as well. So it took that as its initial problem, and then out of this came this more general product called PureWeb, which is not specific to medical imaging, but you can then take really any, graphics or processing intensive application
any
and apply it to really any problem that is out there that has this issue.
Well, I would have to say that there's the outlook for Calgary Scientific must be fairly rosy, because there's only data getting larger. It's going to be more difficult to deal with.
Yeah.
I mean, we deal in video. This is a fairly large data file in general.
Right.
And so we have some experience with. We're not talking about petabytes and terabytes per second or anything like that. But that is a huge opportunity going forward. So congratulations with that.
Oh, thank you.
And congratulations with your success on the Cyber SKA project. It's been fantastic to speak with you.
Yes, thank you very much.
So thanks for coming on, and good luck again with the continuing relationship with that larger project.
Okay, thank you. It's been a pleasure to talk to you.
You're welcome.
Thanks.
So once again, ladies and gentlemen, we've been speaking with Cameron Kiddle of Calgary Scientific out of Calgary, Alberta. And we've been talking about the Cyber SKA project. Stay tuned, because we're going to be bringing up more interviews here at the Analytics, Big Data and Cloud Conference at Fantasyland Hotel in Edmonton, Alberta.